Hello everyone, welcome back to my channel. So in today's tutorial, I am going to discuss about the inverting operational amplifier. So let's move on. In our previous video, we saw that the transfer characteristic curve of an op-amp. This is the transfer characteristic curve. To work as an amplifier, the op-amp needs to be in the linear region. So that the input and output has a linear relationship. But in the open loop configuration, the linear region is very small. So the input signal cannot be amplified much. So to get an amplified output in the linear region, we need to have a closed loop configuration. For that, we need to have a feedback from the output to the input side. There are two types of feedback that we can take from the output to the input terminal. One is negative feedback and the other positive feedback. Providing a feedback from the output side to the inverting terminal or the negative terminal is of the input side is the negative feedback. Now in this figure we can see that we are providing a feedback from the output side to the negative or inverting terminal. So it is negative feedback. Now positive feedback is that providing a feedback from the output side to the non-inverting or positive terminal. Next, we have discussed about both positive and negative feedback. But we cannot use the positive feedback alone as it leads the system to unstable. So to control the gain of op-amp, we need to go for the negative feedback. There are three ways by which we can apply input to the op-amp. Applying input to the non-inverting terminal and grounding the inverting terminal. Applying the input to the inverting terminal and grounding the non-inverting terminal. And providing the input to the non-inverting as well as inverting input terminal. Now, providing input to the inverting terminal and grounding the non-inverting terminal. Here we can see we are providing input to the inverting and grounding the non-inverting terminal. Now, let's assume that AOL open loop gain is about 10 to the power 6 and output voltage is AOL multiplied VD. Here VD is the differential voltage. That means the difference between V plus here the V plus the non-inverting voltage and V minus the inverting voltage. And the difference between these two is the VD. Now assume V out is 10. So the VD will be 10 microvolt. As the voltage difference is very small, the V plus is almost equal to V minus. So V plus and V minus are virtually shorted. Now in this case the non-inverting terminal is shorted as it is grounded, so the voltage V plus will be 0. So the inverting terminal will be virtually shorted. So here we are finding that V plus equals V minus equals 0. Now let I1 is the current flowing through R1, this resistor, and the I2 current is flowing through R2, this resistor. As the input resistance of an op-amp is very high, so no current can flow through it. So no current is flowing through the op-amp. So I1 equals I2. Now if we provide a KCL equation, then we will see that I1 equals VI, that is input voltage, minus V minus, that is the inverting terminal voltage, divided by R1 equals V minus V output, that is the output voltage, divided by R2. Now we have known that V minus equals almost 0. So here it will be VI divided R1 equals minus V output divided R2. So we will find Vi divided V output equals minus R1 divided R2. This is called the closed loop gain of an inverting op-amp. Here, the negative sign indicates that the output is 180-degree phase difference with the input. So, by controlling the R1 and R2, we can control the output voltage of the op-amp. So, thank you so much for watching my video. If you like my video, then please press the like button and subscribe my channel. Thank you very much.